Hey there, we are on Chapter 3, Lesson 4, and we are multiplying decimals by decimals in this chapter. Now, I want to start this off, instead of doing this real world link, I want to use this area right here of our page, and we're going to do a different kind of real world link, and we're going to use money. So, take a look at this. I have 3 dimes here. So, 3 dimes is how many cents? 30 cents. Now, what if I wanted to split up 30 cents amongst 2 people? So I would have to divide. Basically, I want to find what's half of 30 cents. Let's write that down. What is half of 30 cents? What is half of 30 cents? Okay, now, if I'm going to divide up 30 cents into 2 groups, 2 people, each person can get a dime, and then I have to break this dime in half, right? So hopefully I have change. Voila! All right, so now this dime was worth 10 cents, and 2 nickels is 10 cents. So now I can split this up evenly, and 30 cents divided into 2 gives each person how many cents? 15, right? So I know that half of 30 cents is going to equal 15 cents. Now let's think about that, because it's going to give us a little lesson about multiplying decimals by decimals. So our answer needs to be 15 cents. So think about this. Half of 30 cents, that could also be written as half of 30 cents would be this, right? $0.30. And then remember, of in math can mean to multiply. So half of 30 cents, this could be a multiplication symbol. So 1/2 times 30 cents. Now let's write them both as decimals, and we know that 1/2 as a decimal is 5/10, because 1/2 can equal 5/10. 1 times 5, 2 times 5. So 1/2 is 0.5, 5/10. Half of 30 cents. Now, let's multiply 0.5, so 5/10 times 0.30, 30 hundredths. Let's multiply it and see what happens. I'm going to put this on the top when I set it up, because if I'm multiplying, 30 should go on top of the 5. So I'm setting it up just like we did in the last chapter, and I'm kind of ignoring the decimals. And let's multiply here. 5 times 0 and 5 times 3. So it's kind of like I was ignoring all of this stuff and just multiplying 30 times 5. Now, in the last chapter, we learned that to put the decimal into the product, you need to take the decimal out. So that's 1, 2. And look, we have one here, 3. So we took it out 3 places. We need to put it in 3 places. 1, 2, 3. So this is our answer right here. Now let's take out this 0 and let's just focus on what's around the decimal. 0.15, 15 hundredths, or if you put a money symbol here, 15 cents. So when we multiply decimals, we multiplied half of 30 cents, 0.5 times 0.30. We ended up with 0.15. That represents 15 cents. That all worked. So this trick here of setting up your decimals to multiply and kind of ignoring them, and then taking out the decimals, putting them back into the product, works. So that will be our trick for this chapter. All right, so let's go ahead and turn to page 202. Can you believe we're in the 200s already? And get started. this page 202, at the top the heading says multiplying decimals, and we have two examples, one totally done for us, one that breaks it down for us, and then A, B, and C that we want to try. Then on page 203, it's annex a 0 again. So just like what we did with our previous lessons, we're going to have to annex a 0, and it's usually in the product, so we can, if we move the decimal out 4, we've got to move it back in 4. We might have to annex zeros in order to have room to put it back in that much. So did one for us, breaks it down. We try 3, just like on the other page. And as usual, we have one more example before the guided practice. And it's a story problem. So we'll get a little practice with story problems too. All right, here we go. Let's read about multiplying decimals. It should tell us the trick here. So, when multiplying a decimal by a decimal, multiply as with whole numbers. To place the decimal point, find the sum of the number of decimal places in each factor. The product has the same number of decimal places. So here's what I'm hearing here. You're just ignoring the decimals and multiplying it like they are whole numbers. Then, to place the decimal point, you find the sum of the number of decimal places in the factor. So you add up how many decimal places are in the two factors that you're multiplying together. And the product has the same number of decimal places. So it's like you have to take it out of the factors and put it into the product, just like we did right here. We multiplied just like normal, 30 times 5. Then to place the decimal, we added up, we found the sum of how many decimal places in the factors. So it was 1, 2, 3. And then we put it back into the product, the same amount of spaces, 1, 2, 3. So let's put that in simpler words. Let's write this here. Where do we have enough room? We'll just start it here. Multiplying decimals tricks. Multiplying decimals tricks. The first thing is set up the factors like the decimals aren't even there. So set up the factors like, I'm just going to say a normal multiplication problem. So that's how you set it up. You're going to be multiplying like normal. But then when you do the decimals, let's go back down here. You think about taking out the decimals from the factors and putting it back into the product. So think about taking the decimals out of the factors and replacing the decimal in the product the same amount of places. So however many you take it out of the factors, you have to put it back in that same amount of spaces into the product. Okay, so pause it if you need to get that still. And we're going to look at example 1. So let's do these two things. Set up the factors like a normal multiplication problem. Take the decimals out of the factors, put them back into the product. Now, they estimate first because they want to see if their answer is going to make sense. So 3 6/10 times 5 hundredths. 3 6/10 is similar to 4. 5 hundredths is similar to 0. So your answer should be really close to 0. It should be a really small number. So they set it up with 3 6/10 on top because it would just make sense that you would put these 36 on top of 5 if you were multiplying 36 times 5. So 5 times 6 is 30. 5 times 3 is 15, 16, 17, 18. Decimal came out 1, 2, 3. Goes back in 1, 2, 3. Now, that 1800ths or 180 thousandths, however you want to say it, is really close to 0. So the answer makes sense. And this says once you place the decimal point, you can drop the 0 at the right. So you don't really need this anymore. You can just call it 1800ths. You know what? Just to show you, that's what we did here. Instead of saying 150 thousandths to make it be like money, we just dropped that 0 and called it 15 cents or 1500ths, $0.15. Okay, let's look at example 2. This one we have to kind of break it down a little bit and set it up. So 112 thousandths times 7 2/10. 112 thousandths is closer to 0 than it is to 1. And this is close to 7. So our answer is going to be real close to 0 again. Now, how many decimal places does this have? 1, 2, 3. And this has 1. So the product is going to have the sum of the two factors, 3 and 1. So it's going to have 4 decimal places in the product. So when we place this down in the product, it'll be 1, 2, 3, 4 right there. Because we have to take it out 1, 2, 3, 4 and put it back in 4. Now look how they set it up. If you ignore the decimals, they set it up so it would be like this. It makes sense that you would set it up that way if it was a regular multiplication problem without decimals. So let's do the math. 2 times 2, 2 times 1, 2 times 1. That is the little placeholder. I usually throw the 0 in there. 7 times 2, 7 times 1 plus 1, 7 times 1. All right, now we add. So that's 4. Cool. Now, this answer, the product is 0.8064. Wow. Let's check for reasonableness. This number right here, is it close to 0? Well, honestly, it's closer to 1 than it is to 0. But when you're working with these small numbers, you can kind of say it's close enough. It's between 0 and 1. So that makes sense. All right, let's do these problems. Now, how would you set this one up? Does it really matter which one is on the top and which one is on the bottom? There are 2 numbers, so I guess it doesn't really matter. So go ahead and set it up first and multiply like normal, and then watch and see if you're doing it like I am. Okay, if you want, you can pause it and do it and then play it. So this is 5 7/10 times 2 8/10. Got to multiply these numbers by the 8 first. So 8 times 7. 8 times 5 plus 5. Add the 0 for the placeholder. 2 times 7. 2 times 5 plus 1. And then I need to add these two. Okay, so now it's where does the decimal go? It comes out 2, so it goes into. Now if you think about this, 6 times 3 is 18. 5 times 3 is 15, so our answer should be between 15 and 18, so that makes sense. 15 and 96 hundredths. Now how would you set this one up? This one has 3 non-zero digits, and this only has 1. If there weren't any decimals in here, I would think of it as 412 times 5 and put 412 at the top. So that's how I'm going to set this one up. All right, then I'm going to multiply. 5 times 2, 5 times 1 plus 1, 5 times 4. Man, part of me just wants to bring that decimal down, but we can't. We've got to take it out. 1, 2, 3, 4, and it goes in 1, 2, 3, 4 right here. Think about that. This is kind of like 4 times 0. So our answer should be real close to 0. If we would have just brought the decimal down, it would have been 20 and 60 hundredths. 4 times 0 is nowhere near 20. So that's why you can't just bring the decimal down in these problems. So 2,060 10,000ths. Wow, that's quite a mouthful. All right, now how would you set up this last number? Honestly, it could go either way because both of them have, think of it as 14 times 37. You could put it either, either way. All right, so go ahead and set it up. I'm going to put this one at the top. And then you multiply like normal. So even if you set it up the other way, you're still going to get the same answer that I am in the end. So I'm doing 7 times 8. 7 times 1 plus 2. Then I don't need to do those, but if I wanted to, I could. Now I'm going to hold that place right here and do 3 times 4. 3 times 1 plus 1. If I want, I could put those 2 zeros in. Now I'm going to add 8. Now, it's a good thing I put these zeros here because it shows you how you can annex zeros, which is where we're headed on the next place. Because look, this decimal comes out 3, 4. It comes out 4 places, so we need to put it in 1, 2, 3, 4 right there. So if I didn't put those zeros in there, I would have just had to annex zeros when I put the decimal back into my product. Now this makes sense because we're using a real small number like 0 times a number like 4, and 0 times 4 is 0, so our answer should be really close to 0. All right. Oops. Did I do that right? 0, 5, 1, 8. Okay. So now we're going to do the exact same thing, but these are just going to be problems where you're going to need to annex zeros in the product. So on page 203, it says, if there are not enough decimal places in the product, you need to annex zeros to the left. This is just like we did in the last chapter. So we're talking about annexing zeros in the product. Okay. So watch how they set this one up. 1 4/10 times 67 thousandths. So, hey, I just thought of something, by the way. I'm going to pause for just a second. On this other page here, when you write the answer down, you could take out that 0, right? So it could have just been 0.206, 206 thousandths, because that's what we talked about up here, how you don't really have to have those extra zeros at the beginning and end in your product. So if you wrote it like that, that is okay. They both are the same quantity. Okay, sorry. Going back to this. So they set it up like this. In this case, it doesn't really matter which way you set it up, but it does kind of make sense to put this one at the top just because it's like 14 times 67 or 67 times 14, but just putting these extra numbers at the top looks right, doesn't it? So they multiplied here. 4 times 7 is 28. 4 times 6, 24, plus 2. There's where that 6 came from. 4 times 0, 0, plus 2. There's where that came from. I put this 0 here to hold the place. 1 times 7 is 7. 1 times 6 is 6. They added and found the sum. 8, 13, 9. Now, when you take these decimals out, 1, 2, 3, 4. Took 4 out. You've got to put it back in 4. 1, 2, 3, 4. So they annex these 2 zeros in order to hold that place. So let's try this broken down one together. How many decimal places will the product have? 1, 2, 3, 4, 5. So we're going to have to put it back in 5 at the end. So again, it doesn't matter which way you set it up because it's like thinking about 45 times 53. And you could set that up either way. So they put this on the top this time. A 45 on the top of the 53. It doesn't really matter. So here we go. 3 times 5. Hey, maybe, you know what? Pause the video, work this out on your own. See if you get the same thing I get. All right, 3 times 4 plus 1. 3 times 0 plus 1. There's my placeholder. 5 times 5. 5 times 4 plus 2. 5 times 0 plus 2. Then we add. Now, it's taken out 1, 2, 3, 4, 5. Got to put it back in. 1, 2, 3, 4, 5. That's why we had to annex zeros. Now, to check this one, or checking it by just showing you how you multiply the whole numbers, like we've been talking about. So it's the same thing. 3 times 5. 3 times 4 plus 1. 5 times 5. 5 times 4 plus 2. Add it. And then move the decimal to the left 5 places. All right, and you still get the same number, the same product. It's just that we added those, we added that decimal into the product. So these two products are the same. So we need to say yes. All right. Now, when you're setting this up, so look at this here. You would think of this as 4 times 32. So when you're setting it up, you'd want to put the 32 at the top. Because watch, I'm gonna write it right to the side. You wouldn't set this up. You wouldn't do it like that. You would do it like this. All right, so when we set this up down here, we want to set it up with the number that has the more non-zero digits on the top. So before we do this, let's write that down. Let's go right here and put a little star and say, for the setup, put the number with more non-zero digits on the top. All right, pause it if you need to get the rest of that. Try multiplying this out. And I know it feels like you want to just bring that decimal down because they're all lined up in this problem, but you can't bring it down. You've got to take it out 1, 2, 3, 4 and move it back in 4 places. So 4 times 2 and 4 times 3. Got to move it in 4 places. 1, 2, 3, 4. Annex a 0. All right, so there's your answer. Okay, how would you set this one up? Think of it as 26 times 205. You want to put the number with the more non-zero digits on the top. Look at 205, 26. I would put that 205 at the top. And think of it as multiplying 205 times 26. 6 times 5. 6 times 0 plus 3. 6 times 2. Placeholder 2 times 5. 2 times 0 plus 1, 2 times 2, add them up. Decimal comes out 1, 2, 3, 4, 5 places. 1, 2, 3, 4, 5, annex the 0, places. Now, remember again, you don't have to put this extra 0 at the end in your answer, so it can be 533 10,000ths as your answer. All right, set this one up. Think of it as 133 times 6. How would you set it up? Go ahead and do it, and then look up and see if you're doing it like I am. Did you put the 1 and 3300ths at the top? If not, fix it right now. You want to put that at the top because it's like this. It would make more sense to multiply that way than it would to multiply this way. All right, 6 times 3. 6 times 3 plus 1. 6 times 1 plus 1. Now, the decimal comes out 1, 2, 3, 4, and it goes back in 1, 2, 3, 4. Annex those zeros. Again, if you would have just brought down the decimal, your answer would have been close to 8, but something close to 1 times something close to 0 should be something close to 0, not something close to 8. All right, let's look at the last example. It's a story problem on the next page. Ooh, cars. Beep. A certain car can travel 28 and 45 miles with 1 gallon of gasoline. So that's how far it can travel with 1 gallon. The gasoline tank can hold 11.5 gallons, or 11 and 5/10 gallons. So how many miles can this car travel on a full tank of gas? So if on 1 gallon it can travel this many miles, we have to multiply it by this many gallons to see how many miles it could travel with this many gallons. And then we'll justify our answer. So they're estimating 28 and 45 is about 30, 11 and a half, or 11 and 5/10 is about 12. So they're saying 30 times 12 is 360. Our answer should be close to that. So look, when they set this up, they put this number on top. It has 4. Think of it as 2,845 times 115. It has 4 non-zero digits, so you'd want to put that one on top of one that has 3. Now look at, when you do this kind of multiplying, and you have a 3-digit number down here, 5 times 5 is 25. 5 times 4 plus 2 is 22. 5 times 8 plus 2 is 42. 5 times 2 plus 4 is 14. Then you have this little 0 placeholder here for when you're multiplying this place. 1 times 5 is 5. 1 times 4 is 4. 1 times 8 is 8. 1 times 2 is 2. Then when you go for this one, you have to have 2 places held. 1 times 5 is 5. 1 times 4 is 4. 1 times 8 is 8. 1 times 2 is 2. You add it all up. 5, 7, 11, 8 plus 2 4s, that's 8 plus 8 is 16, plus 1 is 17, 8, 9, 10, 11, 12, 2, 3. Wow. Take the decimal out 2, plus 1 is you took it out 3, you put it in 3, there's your answer. 327 and 175 thousandths. That is, well, it's reasonably close. The car would travel 327 and 175 thousandths miles, and since that number is pretty close to 360, the answer is reasonable. All right, the next step will be guided practice. All right, for the guided practice, we need to circle 1, 3, 6, and 7. All right, so let's go ahead and do that. 1, 3, 6, and 7. Now, I just have to tell you something. If you're feeling really good about these, like if you think that you're awesome at these, try number 2. This one is hard because it's like multiplying a 4-digit number by a 4-digit number. So it's a lot of steps. So here's the deal. I'm going to tell you the answer to this one. And if you want to do this one for fun to see if you can get it, that would be sweet. So the answer is 29.87127. Do you see that madness right there? Wow. Sorry. Well, wow. Now you see it. So if you want to do that one for fun, go ahead and do it. It's a challenge. All right. Now, how would you set this up? If you're not sure how to set up 1 and 3, you should look back at examples 1 through 4. Don't just watch the video and copy what I do. Actually, go back and try to figure it out. Do you know how you'd set it up? You could set these ones up either way. Do you know how to take the decimal out and put it back in? If you need help with that, go look and see how we did it in these first couple examples and how we did it down here. All right, pause it and do it. Here's how I would set it up. I'm thinking of it as 6 times 5. And 6 times 5 is 30. And I'm taking the decimals out, 1, 2, and I'm putting them back in, 1, 2. So my answer, it could be this, or I don't really need that 0 on the end. So either of those would be the same answer. All right, so how would you set up number 3? Think of it as 98 times 73. You could put either one of those on the top. So I'm going to put it like this. And then I'm going to multiply, and I'm probably going to run out of room. I'm going to put it over here. Jeez, and I put it right over that little 0 thing. All right. 3 times 8. 3 times 9 plus 2. Placeholder. 7 times 8. 7 times 9 plus 5. So 63. 8. Now I need to add. So that's going to be a 4, 15, 11. Decimal came out 1, 2, 3. So it goes in 1, 2, 3. 7.154. 7 and 154 thousandths is my answer there. Now, does that make sense? 1 times 7 should be around 7. Yes. All right. What about number 6? Ooh, how would you set this up? 4 times 212. Think of it that way. I'd put the 212 above the 4. Then I'd multiply like normal. Then I'd take the decimals out, 1, 2, 3, 4, and put them back in, 1, 2, 3, 4. So I need to annex zeros in the product. Here's my answer, which is similar to 0 times 2 should be around 0. And then we have a story problem. Now this is like the story problem in example 5. So you can look back here and see how we set that one up. All right, I'll read it to you and then you set it up. A mile is equal to approximately 1 in 609 thousandths kilometers. So 1 mile equals that many kilometers. So how many kilometers is 2.5 miles? Justify your answer. So if this is 1 mile, I need this times 2.5 to give me how many kilometers are in 2.5 miles, right? So go ahead and set it up. What number would you put at the top? All right, I'm going to do that right here. I put this number on top because I took out the decimals and thought 1,609 should be on top of 25. Okay, now I'm going to multiply. 5 times 9, 5 times 0 plus 4, 5 times 6, 5 times 1 plus 3, placeholder, 2 times 9, 2 times 0 plus 1, 2 times 6, 2 times 1 plus 1. Then I'm going to add. And now I need to work the decimals. 1, 2, 3, 4 places out. 1, 2, 3, 4 places in. Now, does this make sense? 1, well, it's more like 2, right? 1.6 would round up to 2. 2.5 would round up to 3. 2 times 3 is 6. What's 2 times 2? 4. What's 1 times 3? 3. So it's got to be somewhere between like 3 and 6. And the answer is between 3 and 6. 4 and 225 ten-thousandths. So that's how many kilometers are in 2.5 miles. All right, next step, independent practice on page 205. All right, for the independent practice, let's circle 2, 3, 4 and 5, 8, and 11. So 2, 3, 4, 5, 8, and 11. All right, now let's just look at 8 together. That's the story problem, so I'm going to read it for you. By the way, these 4 at the top, you're going to set them up just like we did in examples 1 through 4. Take the decimals out of the factor, put them back into the product, same amount of places. This one is going to be your intense one. You're going to want a little more room for this one, okay? Then, number 8. A nutrition label indicates that 1 serving of apple crisp oatmeal has 2.5 grams of fat. How many grams of fat are there in 3.75 servings? Justify your answer. Okay, so 1 serving has this much. You're going to have to multiply to find out how many grams are in 3.75 servings, almost 4 servings. And then down here, down below, it's just one of our regular problems. You're going to need a little bit more room for this one. You might want to put it over here to show your work over there. Good luck. You can do it. And remember, look back at the examples. If you don't remember how to do it and set it up, look back here. All right, let's check our answers on the independent practice. And if you get it wrong, I need you to pause the video. And I need you to figure out how you got it wrong. And I need you to ask someone if you can't figure out what happened that was wrong. All right? Because getting it wrong and figuring out how to do it right is how you learn. So I thought of this as 37 times 4. That's why I put the 3.7 on the top. 2 decimals out in the factors, so 2 back into the product. This is the answer. For this one, it could be set up either way. Think of it as 52 times 21 or 21 times 52. I had to hold the placeholder here. Took out the decimal, 1, 2, 3. Put it back into the product, 1, 2, 3. There's your answer. For number 4, I thought of it as 62 times 3. That's why I set it up this way. I multiplied. Decimal came out of the factors, 1, 2, 3 places. Back in 3 places to the product. Number 5, I just set it up right here because I needed more room. So I thought of this as 11,361 times 147. That's why I put this number at the top. I did all of my multiplying. These were my place value holders. I added up and I got this at the end. Here are my decimals. 1, 2, 3, 4 out. 1, 2, 3, 4 back in. All right. For number 8, so we were doing, I thought of it as 375 times 25. That's why I set it up this way. The decimal came out 3, goes back in 3 to the product. 9 and 375 thousandths grams is your answer. And then number 11, here's how I set it up. I thought of it as 1,005 times 103. That's why I set it up this way. This second round was a little weird because it was just 0 times everything. So I don't know if you skipped that, but you needed to have 2 holders in this one when you were multiplying the 1 because it's like multiplying 100. All right, the decimal came out 1, 2, 3, 4, 5 places, so it had to go in 1, 2, 3, 4, 5 places. So there's that long number. Okay. If you're figuring out what you did wrong on the ones you got wrong, or maybe you got them all right, you should be ready for the reflection. This is the Chapter 3, Lesson 4 reflection for multiplying decimals by decimals. First, you're just asked how many decimal places are in these numbers. So put how many decimal places there are. And then say how many decimal places would be in the product if you multiplied those two together, and explain why. How did you get this number right here? Number 2, how would you set up that multiplication problem? Circle the correct setup. And then say why you would set it up that way. Then, number 3, show your work. So now you're going to actually solve that problem. You're going to show your work. And it says in the product, circle the zeros that you had to annex. So let me show you an example of that. In this one right here, where'd it go? Right here, I had to annex these 2 zeros. So when I put this decimal back in, I had to add these zeros, and I would just circle them because those were the zeros I annexed. So when you're doing that in this one, you're going to be circling the 2 zeros you annex. All right, go for it.